So far, we were discussing about the triple integrals, right? And the simple direct questions, we could solve few problems in the previous class, right? Okay. So today we'll go one step ahead and we'll try to solve the triple integral problem over a given region, right? This is next level of problem. Okay. So solve I is equal to, it's a triple integral over a region R. We want to solve 6z square, right? dx, dy, dz, right? Where R is the region below 4x plus y plus 2z equal to 10 in the first octant. So that's the question. So analyze this very similar. We need to analyze this very similar to how we used to solve the problems in a double integral when a region was given. Correct? Right. So let us try to understand where is this, right? This particular region. So this is, it is in the first octant. So definitely the x, y, z values are supposed to be positive. Correct? That's the first octant. So let me try to draw a first octant. All right. So yeah, sure. Yes. Can you see now? Okay. Now let's try to analyze where is this particular region, right? So that we can understand what which particular region we are dealing with. In the first octant means the minimum values of x, y as well as z will be 0. Is it correct? All the values of x, y, and z minimum values will be 0. That's the first conclusion which we can come to, right? So minimum values anyway. When we write the integrals, right, the lower value is predefined. Directly we know that. Okay, right. Then let's try to draw something. So maybe this is the z-axis. I try to tilt it and right. It's actually slight. It's a bit difficult to draw it 3D, right? Let's try. Okay, so let's say this is the x-axis. This is the y-axis, and the z. Since this is the first octant, all the values will be right positive. Okay. Now, when we are saying that we want to find which region it is, so you see this is the equation of a octant. So it's a quadrant. Do you remember quadrant, right? So when the z-axis also come, right, you draw the z-axis as well, right? So this is x, this is y, and this is z. You see, this you have 8 pieces now, not 4 pieces. The whole space is getting divided into 8 pieces. This is, so you have actually, you see here, now I try to draw neatly. So you see, this is a plane, okay? This is a xy plane. Okay, similar to this, I also have, okay, let me change the color. So say this is the XZ plane, right? Now you see you have 8 different regions, correct? Also, I need to have one more that's like this. See, now you have 8 regions, correct? Right, so that's what one of the region, right? When X, Y, Z all are positive is a first octant, right? So X, Y positive, Y, Z is negative. That's the region which is below right, is the second octant, and so on. Okay, right. So that's the octant part. Now you see this particular given equation is the equation of a plane. It has to be specified because other than unless they specify, we will not be able to write the what you call the limits. It has to be specified. Okay, it's not necessary. No, normally the question will be either in the first octant or in the eighth octant, where all are negative. Okay, because they don't want people to get confused. Somebody might, it's actually a convention. The convention is like, okay, you can take second quarter, second octant like XY positive, Z negative. But somebody might say, no, I will take X as negative, Y Z positive as my this thing. So just to avoid that, right? So it's actually a convention. All right. So just to avoid that, the normal most of the questions will be either all positive or all negative. Okay, so that reason. Okay, right. Now, so you see this is a plane. 4x plus y plus 2z is equal to 10 is a plane, right? In order to identify where this plane intersects each of the what you call original planes, that's xy plane, yz plane, as well as zx plane. We have three different planes here, right? The, like a coordinate axis, you have coordinate planes. So in order to find out the so or you can also find the x and y intercepts, yz intercepts, etc. You can actually find, right? So along the z axis, right, along the z axis, if you want to find the z intercept, you see that it has y and x as it, correct? Right? So x comma y, both of them you put equal to 0, you get the z intercept. What is the z intercept? 2z. 2z equal. So z equal to 5. So that means z equal to 5 is the point where the plane intersects the z axis. Similarly, put yz equal to 0. Y comma z both are 0. You find out, right? Yz 0. So x equal to 10 by 4, right? Maybe 2.5. Okay. Then z comma x, both you put equal to 0. Then we get y equal to 10. So I understand now. So if that is 5, maybe somewhere here I have 2.5, and maybe here I have 10, right? So what is the given plane? The plane is like this. It actually takes some time, right, to adjust what they are given, right, etc. If it is a very complex structure, like we are going to solve the next few problems, right, where you will see that it's actually quite difficult to draw that, because there is a shape which is not standard, not a circle, right? uh, the surface is not standard, like a not a conical or something like that. You get a complex, right? So that is actually hard to express. Now you see this is what is like given this thing. So we are supposed to solve the what you call this particular given integral inside. Again, you see now I'm having difficulty to mark the region, right? So the region is nothing but the yz plane, zx plane, xy plane, and this given surface, this given plane. It's middle. You see there is a volume, right? Inside this, you see a volume there. That's the region which they are talking about, right? So it's like in a corner, right? In a corner of one room. That's what is this corner. You try to keep a triangle, right? So there is a volume between the corner of your room and this maybe a book, correct? So that region is what they are talking about, right? Right. In this region, we are supposed to do the integration. Now, so anyway, so we want to do the integration in the following format. So let us start with let's start by writing the limits first. Okay, so you fix, right? Always the idea is that you try to reduce the triple integral into double integral, and then you reduce the double integral. Anyway, the standard procedure is the same thing, but what do you mean by changing the double integral in sorry, triple to double? You will understand. Okay, so let me try to write in this way. This is one option. Again, I don't know what has been followed in your college. Just see whether the method which I am teaching suits you. All right, so I will just write triple integral. Right, so I want to do this, the integral which we are talking about. Anyway, let me write once again. This is over a region R, right? 6z square. I'll write the z first. Okay, so I'll try to write dz, right? But dx dy gives you the area, correct? Right, so you can actually try to normally we have one convention. That the convention I'll write here. If you have, you can, you have a d, maybe dx dy dz. This can be written as a dv. It's a volume, small volume, right? Small change in x into small change in y, small length into small width into small height. So you have a small volume, correct? Similarly, if you have dx into dy, small length into small width is equal to small area, right? So normally we follow this convention as well. Okay, so in the sense, in the question they can also mention this as simply dv. Okay, so this is a possibility, right? So if that is given, don't get confused. It means normally you can replace it by dx into dy, right? So what I do now, I separate this, right? I have, anyway, let me write it in this way. Dz, maybe I'll do dx dy or dy dx later. I'll decide later, right? Simply write this. I write like this. But you see, now I can try. What I try to do, I'll try to find out the range for z. Anyway, minimum of z is 0. That is known to us. What is the maximum of z that I can find using this equation? Correct? That is the equation of z. Is it fine? Right. So let us try to, in a sense, I'm trying to eliminate the z completely from my integral. Correct? So when that is removed, when the Z is completely eliminated, you are going to, the volume will be reduced into the area which I am marking. You see, this is the area, right? Because no height, right? Z is eliminated, means only XY, correct? So when I integrate this particular function with Z, Z is gone. There is no more Z. Means you have only XY, which is a double integral, right? So this is my approach. Okay, maybe this worked most of the time because people could understand this easily, right? For any problem, any triple integral problem, you try to solve, right, one of the variable first, then you see what else can be done. Okay, so I'll keep this double integral over a region R, but what I do, I substitute my Z value. So Z is equal to 0. What is the maximum value of Z? I need to decide. Okay, so I'll do the calculation maybe over here. So they mentioned that this is 4x plus y plus 2z equal to 10. So what is the value of z? Can you calculate? Z is equal to, there is 2, so it becomes 1 by 2 into 10 minus y minus 4x. Are you okay? I say I calculated z. From the given equation, I simply calculated this. So likewise, recall the problem we did. Like I had y equal to x square, something like this. I know the minimum value of x is 0, right? But what is the maximum value of x? You, if at all this is y equal to x square, you used to write x equal to root y. You used to calculate that, right? So same thing I did now, but it is for z. Okay, that's how the z varies. So you know now what is the highest limit of z. That is equal to half of, right? Anyway, I think all the values we can try to simplify, or anyway, let's try to write it. Doesn't matter. So this is 1 by 2, 10 minus y minus 4x, right? So do this with respect to z square, because z is available. That's why I don't want to do with x or y. Z is available, just eliminate that. 6z squared, right? Okay, that's why I'm doing. So into this is dz dx dy. So out of which right now I'm trying to solve only this part. Actually, it's a simple one-dimensional integration, correct? Right, right. So let's try to. Anyway, you can solve this, or we can proceed further. So, right, anything is fine, right? So now I'll try to look at. Now you see, this whole problem is reduced into the following problem, right? I'll try to write that now, so that right, the integration we can do later as well. All right. Now you see. Now what I'm having only x and y axis, correct? So I told this is the x axis, this is the y axis. So refer to the above diagram containing three different axes. Only try to write the blue colored shaded region, correct? So y-axis has 10, x-axis, sorry, y-intercept 10, x-intercept 2.5. Okay, so let me write that. Y-intercept 10, x-intercept 2.5. This is 10, 2.5. Okay, now what you want? It's a simple problem of, right? What is this? This is a double integral, correct? What I do, you simply have to consider a strip. I'll consider a strip like this. So bottom end is on x-axis, right? So let me write the coordinates first. So what is this coordinate? 0, comma 0. This is 2.5, comma 0. This is 0, comma 10, right? Out of which now I see that x now I'll update. So this is equal to integral over x varying from 0 to 2.5. Okay. Next, you write what happens to y. Y varies from 0, that's the minimum value. But what is the maximum value? Maximum value is on this. Ah, yes, you don't have to consider z at all because z has been eliminated by this time, right? Yeah, so your equation will be 10 minus 4x, right? Equal to 0. So y equal to, I can write y equal to, as you told, 10 minus 4x, right? So y is 0 to 10 minus 4x. Next, you write whatever you had written. So that is z is equal to 0 to 1 by 2 times. This is 10 minus y minus 4x, right? 6z squared dz dy dx. Now this is in the proper form. Okay. So we need to solve this, right, to get the answer. All right. Will you try to solve? Yes, please. Yeah, that's all. That's all. So that means the calculation goes like this: 5 minus 2x raised to the power 5, right? What's the answer you are getting? How much? Uh, 5 minus 2.5. Are we getting the same thing? Yeah. Well, this comes 0, right? Possible. I think you also got 0 somewhere earlier. Oh, sorry, I missed it. Maybe, but I don't know how we are coming to 0. Okay, let's take it. Okay, let's proceed. Here we don't have any other option, right? You see, you substitute 2.5 and you put 0 over there. What happens? It's not 0, right? I have an answer. Sorry, it's not 0. When you put 2.5, yes, it becomes 0. But when you put 0, what happens? It's a 5, right? Do the other calculation. Yeah. You have to substitute all that. That's what I was thinking. How can we get the 0? So this is minus 1 by 10 into first part becomes 0. Then I have a minus, right? This is 5 to the power 5 divided by 5. How much? 62.5 everything. Okay, let me write. All right, let's proceed further. Next question. Solve I is equal to triple integral over the region R 12 y minus 8x dv, right? Where R is the region, behind y is equal to 10 minus 2z and in front of xz plane. Bounded by, see, z equal to 2x, x equal to 5, sorry, z equal to 2x, x equal to 0, and z equal to 5. Z equal to 2x, x equal to 0, and z equal to 5. Need to imagine what is the region given. We'll try to draw. Okay, the question is fine, right? So they say that it is a region behind something, behind the y equal to 10 minus 2z. All right, y is equal to 10 minus 2z, right? If you simply look at the two dimension, this is going to be a straight line. Okay, y equal to mx plus c, right? But in a three dimension, this becomes a plane. Okay, so fine, we'll come to that later. Let's try to draw the easiest part, right? By like looking at the given data. So it says that in front of the xz plane, so behind this, right, there is a plane y equal to 10 minus 2z. It's behind that. Okay, and it is it should be the region which we are looking now, right? Should be in front of the xz plane. Z plane. So x z plane. So I have to have a x z plane as a reference. Whatever region I'm talking about is in front of the x z plane, because x z plane is easier to understand, right? So let's try to draw that now. So very similar to the one which we have seen earlier, right? And you see x equal to 0 is nothing but on the xz plane. Anywhere you see x equal to 0 will be what? X equal to 0 will be yz plane, correct? So you have to get the boundaries of the region which they are talking about, correct? That's the only reason why they can be. Otherwise, I don't see any other this thing. Okay, so that means let's try to analyze further. Okay, so let's say, let me try to draw. I need to look at a yz. Okay, let's look at the details first, complete details. So it says that z equal to 2x, right? So z equal to wherever is your z values, that will be twice that of the x value. That's one boundary, right? And the maximum possible value is only up to z equal to 5. So you see, right? That means you are able to get the boundary region, right? So what should be the boundary region that you have to decide? So I know that z varies from 0 to 5 because I am looking at xy plane. XY plane will always have the value of z is also 0 only, right? XY plane. Sorry, xz plane, my mistake. Xz plane. Y is equal to 0. So I got a limit of y as, correct? Y will be minimum value of y is 0, maximum value of y is equal to this one because behind, right? Behind means it should be lesser than this one, right? So I could understand that from this equation. So, right? So let me write the limits first, then we'll try to link. So I know that y will be 0 to 10 minus 2z. Are you okay? Then you see, right? Anyway, when I do this integration, let me see, I got the complete information about y. So I can do this integration first. Are you okay? Innermost integral. Now I have two options. You see, x is equal to 0. Sorry, z is equal to 0. My mistake. What we'll do? Okay, we'll do the x first. We'll try to do the x next. So x equal to 0 minimum, I know, right? 0 is the minimum, right? 2, can I do z by 2 because x equal to 2x is given, right? Are you okay? Now you tell me what happens to z. 0 to 5, right? That's all you got. You don't have to draw anything. So that's why the data is given, just to give you more clarity. Only thing is, how do you do the integration is important. What order? Behind means y's maximum possible value is this one, 10 minus 2z. Huh? Then also you need to identify that, okay, right? This is how it is, right? So you always start from, see, in front of means more than, behind means less than. So always you will get something like this in the given data. They made it simple, that's all. They made it very clear that on a xy plane, the y is equal to 0. That's the lower limit. Means this is the upper limit. They have given the data directly, actually, right? They could have given it in behind z equal to something and in front of that. Then you should have, right, done something so that you get the y limit. Okay, it's actually the data straightforward thing. Okay, right. Now, so we'll do one thing. So it's actually simple integration. So therefore, I is equal to, just decide what you are going to do in which order. So outermost one will be constant. That is z is equal to 0 to 5. Then you write the x value in terms of z, because by this time you will be eliminated. You will not be having y, but you still have z. So x is equal to 0 to z by 2. Last, the innermost one is 0 to 10 minus z, 10 minus 2z, right? So, yes. So this is 10 minus 2z, right? Then 12y minus 8x. Innermost one will be dy. Then you do with respect to dx. Then you do with respect to dz. Okay. So I hope the method is clear. Anyway, you will be able to solve this, I guess, after this, right? You solve it. Maybe the next session you give me the answer. All right. I'll proceed further. Otherwise, we'll be stuck in solving the problems. I want you to look at the other versions also, other types of problems, so that we finish up the region related problems too. Okay, right. Let me move to the next question. Right here also, my intention is just to make sure that you identify the boundaries, right? Minimum and maximum values, so that you can directly uh, solve it later. So this is the next question. Solve I is equal to triple integral. Uh, okay, right. So the region wise, I would like to stop there. I want to go to the volume problem. Anyway, this is also equally important. You know, there will be no, in the sense. No integral given, you have to decide what you should do. This is the next type of problem. Okay, so this is the question. Find the volume. Correct, you have the problems based on volumes also, right? Find the volume of the region below z is equal to 4 minus xy, right? You see, now this makes more sense, right? Because z equal to 4xy and above xy plane, bounded by 0 less than or equal to x less than or equal to 2, and 0 less than or equal to y less than or equal to 1. Almost everything is given straightforward fashion. So I'll just show you the question again, right? So can you guess where is it? See, the below the z equal to something means upper value of z is given, right? And it says above the xy plane means minimum value of z is given, right? So you see, this is other values are directly available, x and y, it's directly given. So I is equal to triple integral over a given region R. You should simply solve dv. Correct. So triple integral over the region R, dx dy dz, right? In like we used to solve area as simply dx dy, volume will be dx dy dz in rectangular coordinate system, or the one which we are solving, right? So now you see, do you have any of the parameter which has the variables in it? Yes, z has the variable, so you need to solve x z first. So I'll do like this. Okay, so correct. So I'll start with the x. X starts from minimum value of x is 0, maximum value is 2. That is given. Then you do for y. Minimum value of y is equal to 0, maximum is 1. Now you write for z. So z is equal to minimum is 0, maximum is 4 minus xy. Okay, solve in the same order, dz, dy, dx. Right? A straightforward question, right? Wherein I need to find out what region they are talking. Just use that, find out the limits for x, y, z, and solve. Are you okay? Right. So I think you should be able to solve this. I expect answer in the next class for this as well. All right. Right. Let me move further. One more I want to solve. This is actually, yeah. No problem. No problem. I can share this. All right. So immediately after this class, you'll get this complete notes, whatever we were writing so far. Okay. Right. Then let me move on to the next question. I is equal to. Oh no, we are solving the problems based on the volume, right? So I don't know. So this is the question. Find the volume of region below z equal to 8 minus x square minus y square, above z equal to minus of root of 4x square plus 4y square, and inside x square plus y square equal to 4. Okay, slightly complicated area given. So upper limit of z is given. Yes, we understand. Lower limit of z is given. Yes, we understand. Okay, but inside is circle, right? This is a circular shape. XY will vary according to a circle, but Z varies in a different shape, right? So I'll try to write a very rough diagram because it's not going to be accurate, because the upper and the lower limits of Z, they are complex surfaces. They are surfaces. Okay, they're not a plane. They are surfaces. The upper, I'll try to write something. Okay, let me try to draw a 3D. Z is directly given. I don't have to draw anything, because what we know now, I can direct. Absolutely fine. That's what I was expecting. Since you are aware of that, directly let's do. Then I don't need this, right? Because it's a very complicated thing to, right, to analyze. Yeah, yeah, yeah. That's correct. That's correct. So let's try to do that. We understood that. Therefore, the required integral is triple integral. So I write a region R, but I'll write a Z now. So Z is equal to the least value, that is minus of root of, it's above this one. So 4x square plus 4y square. Okay. And what is the upper limit of Z? It's 8 minus x square minus y square. I write a dz here, then the remaining part will be some dA. dA is dx dy. So first you can solve this part directly. Is it okay? So let's try to do this. So this means this is equal to integral. I have to do a double integral over R, that I will decide later. So it's simply z dz. Just z, sorry, no mistake, not dz, because dz has been integrated to get this. So it's z starting from minus of root of 4x square plus 4y square till 8 minus x square minus y square, right? I have a dA remaining outside, right? So this is equal to double integral over R. Substitute. What happens? 8 minus x square minus y square, first part. Then I need to subtract this. So minus of minus becomes plus root of 4x square plus y square, 4y square, right? This needs to be now integrated over this. Now you see what exactly happened here is I am going to have only a circle now. So this is x, this is y, and what you have here is a simple circle, right? So the circle is, this is the one given. I just have to integrate and get this area. So what do you do now? Around this region, this is the region given. You have to solve this given integral. It's a double integral problem. So how do you deal with that? Recall what you did when you have right. See, it's difficult to find the x and y variable. Anyway, it is possible. Okay, okay, that's one possibility. Otherwise, why don't you see, whenever there is something like a circle or related to that, it's easier to convert this into the polar coordinate. Correct? Are you okay? Because you see, I can see x square plus y square directly inside that. What is that? That's a r square. Theta will vary from 0 to 2 pi. R is going to vary from 0 to 2. 0 to 2, right? Because the circle is r square, right? So it's actually easier method. You decide what you can, what you prefer, right? So what I do, right? So this looks easier for us, right? So what I do now, so this is equal to, let's try to substitute, right? So I can try to write x square plus y square equal to the r square. That's the equation. And what happens to the dA? dA is the area. It's r dr d theta, isn't it? dA is dx dy. So what is dx dy? R dr into d theta. So do the substitution and just calculate the limits now. So, right, you can do with respect to r or d theta. Since my function is going to have r, first let me do the integration with r first. So r is equal to 0 and r goes all the way till 2. And theta I'll do outside 0 to 2 pi, complete circle. Otherwise, you do 0 to pi by 4 and multiply that. Sorry, 0 to pi by 2 multiply by 4, right? Anyway, so that's fine. Now the term becomes 8 minus, so the x square plus y square becomes r, correct? Then I have, see, root of 4 x square plus y square. So what happens to 4? It comes out, correct? Plus 2. Root of x square plus y square is root of r square, that is equal to r into r dr d theta. Pretty simple, right? This is, I'll write the final equation to be integrated. 0 to 2 pi, 0 to 2, this is 8r minus r cube plus 2r square dr d theta. That's the final volume required. One of the integral has been performed. So just remember, I wanted you to understand the concept that whenever a triple integral is given, one half you can definitely do normally, and second half you can convert into polar or the reverse, right? It's very pretty much valid. I just wanted you to understand that concept, so only I solved this problem. Okay, so this answer anyway you solve by yourself, and in the next class you can show. All right. Right, I will share you this document now itself. All right. So maybe tomorrow I'll try to extend because too many concepts do exist over there. Okay, to cover. Mostly tomorrow we'll go with the applications of triple integrals. Okay, we'll start with that.